Everyone, welcome. As I said earlier, this is the last innovation showcase of the day. Last but not least, though, Trig Drones. That's an exciting one. You always know it's going to be a good session when drones are involved. And knowing these two companies and the projects they have, I'm really excited for you to hear what they have to say today. So what is a trig? I know that word has been thrown around a lot today. Some of you may have heard the announcement from the minister this morning about our upcoming trig program. Some of you may have been part of a trig. But for those who don't know, a trig is a Transport Research and Innovation Grant. They are a program that is run by Connected Places Catapult and Department for Transport. And again, my apologies, I forgot to introduce myself. I've just been on screen all day, so that's my bad. My name is Emma Hughes. I am an SME Development Manager at the Catapult, and one of my favorite jobs is looking after all the trigs. So I work with Rick and Garrick quite closely on the Trig Drones program, as well as kind of the other ones that we've heard from today and have also launched today. So very exciting things about the trigs. So today, Trig Drones. Very exciting project, launched earlier this summer, and we have about 2 months left, if I'm correct, Rick. We end at the end of November. So very soon we're starting with, we'll be finishing up the Trig Drones program, but some amazing tech regardless of where they are in that process. So the 2021 drones program was delivered part of a wider DFT Drones Pathfinder program, which I think some of you may have heard if you tuned into Hannah Tew earlier today. She talked about the wider Drones Pathfinder. So this trig program sits within that. But what we're looking to do is to accelerate the delivery of near-to-market drone flight and air traffic management capabilities within the UK. So within this opportunity of the trig, there are a couple challenges that we've been looking at. We've been looking at challenges such as Onboard Detect and Avoid, DAA. That'll be an acronym that I'm sure some of you will either know or you'll learn by the end of this. Autonomy and communications. And so through the 6-month program that the cohort has been with us, we're helping take early stage research and development studies and kind of integrating them into UK airspace. So working with DFT, working with CAA, which is the Civil Aviation Authority, if I'm correct. Guys, this is all new to me, so we're rolling with it. Yeah, I got it. That's good. But working with them to kind of help bring their technologies to market. And as I said before, let me tell you some really exciting tech that we have today to show you, as well that will come out of the cohort later on. So some quick housekeeping. For those that have just joined us, haven't been on this platform before, question and answers are on the right-hand side. In the chat box, I'll be looking there, as well as the Q&A tab. If you have specific questions for someone, please feel free to reach out to them and send them a chat privately, schedule a meeting, try and connect. You can attach, you can go to people's LinkedIn profiles as well if they've completed that. So really great tools there. Today is all about connecting people, about sparking kind of connections, relationships, and accelerating innovation. So it's a really exciting day. So you didn't come here to talk to me, to hear me talk, apologies, but you came to listen to Rick and Garrick. So first, I'm going to ask Garrick to present. So Garrick is from Rinicom Limited, and he's going to be sharing his pitch with us. So Garrick, it is over to you.
Good afternoon, ladies and gentlemen. Pleased to be here. Apologies for some background noise here. It's out of my control, unfortunately. So as Emma said, kindly introduced, so I represent the company Rinicom Limited. We are proud to have a grant from Catapult, and it's called Mesh in the Sky. And I'm going to talk about Rinicom in general and what do we do. And also at the end, I'll finish with the description of the work, what we are doing for the Catapult. Emma, are you going to share the slide?
Yes, I am. I'm just getting them right there. So do you see those?
Yep.
Perfect.
So that's us. Next one, please. The company overview. The Rinicom, we started it in 2002. So next year we will be 20 years old, but we are still young in spirit. And the way the company works, our main expertise in secure communications, and that's been the core of our activity. But we also do a lot of innovations. And as we develop some technology, we spin it out as a separate company. For example, in 2017, We did a lot of work about the use of artificial intelligence in the medical, in healthcare. We've developed this system which allows to predict the heart attacks and kidney failures 6, 4, or 8 hours before it happens. That kind of raised some interest. A new company was created called Rinicare, and it is now the company on its own right. It employs today 20 people. It has the systems deployed in various hospitals in the UK and around the world. Recently, in 2021, we did a lot of work in anti-drone systems. So one of the first pioneers who built the anti-drone systems. The system will detect, track, and classify the drones. Again, the system raised a lot of interest. It is currently being installed at Heathrow Airport at quite a few of our systems. And I can say this because there was recently a press release. And we set it up, spin it out into a new company called Renicom Intelligence Solutions. And this company purely works now for the anti-drone market. And we have quite a few early successes, despite what the company is less than a year old. Back to Renicom, we are still focusing on the secure communications, and that's what we do. Today we are about 30 staff and growing rapidly. Most of our staff are engineers. Surprisingly, we still don't have a sales team. And what we work through the partners and through the word of mouth and through reputation, because many partners and customers, they come to us for many years now. We are privately owned and profitable, and in the last 5 years, we received the Queen's Award for Excellence in Business in 2013 and 2018. The next one, please. So the mission statement, everyone has one, we also have, but it's basically, we aim to become one of the best providers for the customers in the first responder and transport sectors. And it's not only providing the system, but also helping our customers to make it very profitable and to be more efficient. We are proud to have some very good relations with our partners. The next slide, please. This is our company structure. As you can see, it's very flat. Sean, who is the CEO of the company now, he runs the company, and it's a very, very slight. And you can see it's heavily engineering skewed. The next one, please. This is our pride. Some of the partners what we work with, and these are the partners what allowed us to put the logos on this slide. You can see some very big names, you recognize them, and some the new names which I believe what they're coming up. And this type of markets is also quite different. You can see from Bentley Motors, we supplied some systems for the latest Mulinex car, to Transport for London, to the BT and so on. The next one, please. Our products. Next one, please. As you can imagine, in the 20 years, we've done a lot of products. Most of our sales, as I said, were abroad. Like 80% of our sales until recently were export. What I selected here is kind of ultimate product what we did. It combines a lot of technologies what we did separately and puts them into one. It is called Sniper Control and Observation System. So this is what we supply for the protection of VIPs. And that's basically, we build everything except the rifles. And the aim of the system is, when there is a VIP event, it needs to be protected. The snipers are positioned in the 4 different locations to protect the area, but the control of the snipers is done centrally from the vehicle, which is parked maybe about a kilometer away. So the aim was to provide the video from each of the sniper teams to the control machine with the minimum latency, and then to provide the signals to them to who should be taking which actions, and then all the videos and everything are recording. On the slide here, you can see, for example, the 4 videos sent from 4 sniper teams, and then the target has been identified in the red circle, and this target is sent to all the sniper teams saying this is your target. And whoever sees the target, it's locked with the green light. Everyone else is with the red waiting for the command. This was our legacy system. We've done it with the technologies which no longer new, although they've been quite new about 10, 15 years ago. So now we are developing the new solution. The next one, please. Which I will ask Sean to mention about. That's another one of our products what we're developing currently. Sean, could you step in, please?
Garrick, I don't think Sean is on the screen, so would you be able to talk about this one?
Yeah, I will be able to talk. So this project is actually, we all know about the importance of like renewable energy and so on. So we work with the company, shipping company, MacGregor, or the Edda ships, Edda Mistral. And what they do, they provide the services to the wind turbines in the sea. And the way it works, basically, the ship is like a hotel. It goes from one wind turbine to another, and the team of engineers goes from the ship to the wind turbine, and they stay there to do the service while ship goes to our wind turbines. And after certain time, the ship comes and collects the people back on board. It's all simple and easy to say when it is a quiet weather and no rough seas, but being in the North Sea, this rarely happens. So very often the ship has to wait a lot of time until the sea is quiet, so it's safe for people to cross on the bridge from the ship to the wind turbine. So what we did, we've developed the solution based on the AI and video analytic and using some tags and so on, which allows to make this transfer more stable. So basically, we measure the relative movements between the ship and the wind turbine, and we compensate this movement with the AI technology. That's one of the solutions what we are recently developing, and we are thinking of spinning it out into a new company as well, maybe in the near future. The next one, please. So that explains basically that what is happening in each of the sites on the ship and on the wind turbine. So we put some markers, there's some camera, and there is a AI algorithm behind it, which does everything. The next one, please. What I want to talk now is about the project, what is a key for our future, what we call the mesh in the sky. We have a mesh product, which you can see on the video, what we uploaded to our group. And this mesh product, what we supply is for the first responders, and it's basically when there is a disaster and they come to, let's say, the area after an earthquake or tsunami and so on, there is no communication. So they bring this communication with them, they rapidly establish local communication, and they start their operations. It has its advantages. It's been one of the newest products that's been introduced as a mesh system, but it has its limitations. So it doesn't work on a mobile product, and it has some limitations. And also, we decided to move to the next level and apply the concept to mesh connectivity of drones. And this is what we are doing in the project what's called Mesh in the Sky. The next one, please, Emma. So the idea is, it's explained on these cases. So rather than in a conventional application, the drone range is limited by the control signals what you can get. And to extend the range, it's either you need to increase the power of the control signal, but that increases the weight. So on one side you increase the power, but then you reduce the flight time. What we are proposing to use the mesh system, which shows on the figure on the right, where one of the drones will be acting as a relaying station for the other drone. So in this case, we can use existing low power solutions, lightweight, but we can increase the range of the system significantly. And it's not just between the two drones. We are talking about having a multiple drones, like a swarm of drones. And the number of applications where you can use the swarm of drones is enormous, from the search and rescue to the mountains to the military, I have to say, to securities and to civilian and so on. The next one, please. Challenges. We are not the first people who are trying to do this solution. Quite a few people trying to do, but we are approaching it from different points of view. So we are using a software-defined radio, so we can have a fully configurable solution, which could be programmed and could be restructured even during the flight. And it's not just a conventional software-defined radio, but it's also a software-defined radio what is acting as the channel bonding. So it has a radio on board, but it also is looking for other communication systems which are available, for example, 3G system and so on. So it can bond this together, aggregate it as a bigger traffic. So we will have a wider bandwidth when we have a more capacities and so on. To the best of our knowledge, no one done this. We've been successful in proposing this solution for the NATO 118 standard for the what is called like a communication in disadvantage tactical scenarios, which been now incorporated in the standard. And we're now trying to implement and to demonstrate this solution as a part of this project. The next one, please. And in conclusion, we, as we said, we are almost 20 years old company, but we are still dynamic, and we still believe we are young because most of our staff are young. I'm the only one with the gray hair. We are still research driven, and we still pay a lot of attention to innovation. We are financially secure. As I said, in 20 years, we grew up the company purely on the cash flow and on the sales. We don't have any investors or loans or anything like that. And we have, that's our biggest value in strong R&D team, what we have. And we work very, very closely with our customers. When I was starting the business, someone told me, Pritchard, what I'm trying to use it all the time. It says, Garrick, make sure what your products never come back, but your customers always come back to you. So that's how we operate, and that's we'll hope we can operate it for a longer time. And thank you very much for your attention. And again, really sorry for the background music.
No, not to worry, Garrick. I mean, the jazz, you know, it adds a nice dynamic to today. So I'm okay with it. I'm sure some other people enjoyed it as well. So thank you so much. And sorry I couldn't bring Sean on stage. I had my screen full of your presentation. So Sean, my apologies about that. So as I've said before, if there's any kind of questions, please put them in the chat or the question and answer session. Question answer column as well, and or reach out to Garrick, Garrick himself, and he's more than happy to answer those questions. So now, without further ado, I'm going to hand it over to Rick. Rick, the screen and the stage is yours. Rick is from Surveyor, and he's got a really, really exciting technology that we're really thrilled to be supporting as part of Trig Drones. So, Rick, it's all on you. Let's go.
Thank you. No, that's really great. It's really interesting talking there, Garrick, and we're kind of a lot younger, I would say, in our company. It seems we hope to get to the sort of stage that you're at one day, I'd hope. Okay, so I'm going to talk about the Autonomous Swarm Atmospheric Assessment Platform, which I'm starting to realize is a little bit of a mouthful, but it's called ASAAP. And this is our funded D-TRIG project, and we're very happy to be part of this D-TRIG consortium, and it's really helping us develop this and other things within the company. And we have an office now at the Cranfield Eagle Labs as well. My research background kind of helps with a lot of the innovation stuff that I'm trying to do. About 10 years ago, I was working with turbulent fluxes in the US. This is at NASA Dryden, where I'm built a system to measure turbulence from drones. I've also built gas samplers to fly beyond visual line of sight at 9,000 feet to take samples above Ascension Island. I have a PhD in Earth atmosphere exchange of greenhouse gases and aerosol particles. And I'm a big fan of sector development, and I ran a practical UAV course for the environmental sciences for a number of years, funded by UKRI. And also done some plume hunting work in Guatemala at Fuego volcano there. And last but not least here, I developed a sensor technology to put on the back of an eagle. And this eagle comes from Switzerland and was flown with the test system on that. So I'm not a stranger to innovation, but what I like to do now is really bring this out into the commercial world. So I'm part of Surveyor, which is a company that I'm a technical director of, and work alongside Will Kirk and Professor Grant Allen, who's joined us from the University of Manchester. We're very lucky to have a really great team of people who we can draw upon for all kinds of technical expertise, including GIS and programming, and and piloting and so on and so forth. And within Survey AR, essentially we're trying to bring in a lot of the kind of drone services that we feel and we know the market needs. It's not just taking pictures or video, it's about the different types of sensors that we can use on drones to measure things like vegetation health. We're looking at air and water sampling, greenhouse gas surveys and other pollutant surveys, as well as integrating geophysical sensors onto the platforms to automate all of this in order to get a more holistic view of any given environment in order to then visualize that data and pass it on in a usable form to the end user. But what we're looking at now as part of this project, and what's really key is urban areas and urban weather forecasting and air quality monitoring. So we know we have an air quality issue throughout the world, really, and we know with climate change we have significant extreme weather events. And with increasing urbanization, people living in urban areas, it's really helpful to try and understand on a local scale some of the processes going on a little bit more in order to inform people and help with asset management, and for people to be aware and plan and not be as impacted by some of these problems. So we know, for example, how air pollution causes premature deaths, and we know that enhanced weather forecasting will be of great value. And the solution that we're working on is to use a swarm drone system where each one carries a small sensor of some kind, be it a fast response meteorological sensor or a fast response pollution or gas sensor. And we're bringing this system from a TRL2 to 4 through the DTRIG project to understand how it can be used and where the market is and who's most interested in terms of the system, and of course how the system can work. And this isn't without precedent. Further to the Eagle work, at the top here is that you get a kind of pathway of development from, I put these sensors together and popped them on a board and got robustly laughed at when people said, when I told people I was going to fly that on the back of a pigeon one day. But lo and behold, with miniaturization, that's exactly what we did, because pigeons at that time were pretty much the only people who could exist in that space above the urban landscape, where air moves through the city, carries pollution from one part to another, and it blends in this area above the city where the models really struggle, not least because they don't have any data with which to train themselves against. And with these data, I mean, I love a graph. I don't know about you lot, but we have in green is the bird altitude, which is flying over the grey urban rooftops here. So you can see how the bird's flight path changes, and with it we have a temperature measurement in red with these little wiggles, which belie all kinds of information about the heat in that area. And we can see a plume here, for example, which is also reflected in the humidity increase as we fly above a lake area. And the bird rests on the rooftop for a bit and then carries on back to the pigeon loft. It's a racing pigeon. And we could also infer wind speed and direction from the way that the pigeon moves when it flies around in circles, for example. So it's with this now in a changing regulatory landscape where we are able to fly drones in urban areas, provided that we make the appropriate safety case with the CAA. And whenever I approach a kind of a drone campaign, I use this kind of model. So we've got essentially 6 little bubbles and 6 ducks to get in a row, essentially. And with each one, there's a whole bunch of really important criteria, any one of which, if they fail, could prevent the system from being able to fly safely, which is obviously of fundamental importance. And so through this program, we're very pleased to be in dialogue with the CAA about the swarm drone operations, about what we're trying to do. And that helps us to understand the requirements of the platform, which I'll get to in a sec. But we have we're also talking to a lot of stakeholders about exactly what they'd like to measure. I have ideas of what are useful. For example, different kinds of gases, CO2, for example, and NO2, N2O, and particulates within the airborne environment. And then we think about how we need to log this data, how we transmit it back to the base, what kind of wind sensing we need, position and accuracy, all these kind of things. And then what do we do with the data? Where do we push it to? Who wants it? How can we get it into the APIs of useful apps and so on and so forth for people to quickly distill the information they need from this potentially huge swath of data that we can generate? But we want people to be able to get what they need quickly. And with the platform, then, we have to be quite small if we're going to fly in an urban area. We're talking really below about 250 grams, where the kinetic impact, if it were to fall out of the sky, which of course we don't want to happen, but the kinetic impact will be lessened potentially. And there are other risk aversion measures which we'll put in place for this. And we think about what we want it to do in terms of where we need it to fly in order to get the best data for these kind of systems, and how we can have them fly in an automated fashion, automatic recharging and deployment. And of fundamental importance, of course, is the project management and the commercial use cases, and how do we develop the system and fund it going forward, and how do we build and develop the right team to do this. And these are all things that we've been working on extensively throughout this project, and we believe we're getting somewhere. So we have the commercial use cases with urban meteorology and microclimates, and then assessing urban form and the effects that infrastructure might have. If we put in a mitigation measure, we can use this system to quantify the ability of those that infrastructure. And then, of course, with urban air quality, we can measure and assess the same. And I realise I'm just running out of time, so I'm just going to put on the last slide, which is our prototype here. This is it's full of wires and what have you, but actually it flies quite nicely. It's the 250 gram initial swarm prototype, and we look at how we put the sensors on board and how we fit it all together, and then we have the control software and the control software people that we've been working with to understand how best we can bring that into an MVP. So I'm just going to end it there. Eventually, we hope to have some kind of system in urban areas with multiple drones flying regularly, but I'd welcome comments, and I particularly welcome people who think they might be interested in how this system could be useful for them. So please get in touch either through LinkedIn or through the booth where I will be from now, I guess. Thank you.
Perfect. Well, Rick, thank you so much. I mean, the story of the pigeons, that's all I remember from your application was just I was just wowed by that, and great to see how it could apply to drones and what you're going to do. And I think, understanding the air quality around us is so important, and what better way to do that than with drones. And the drones that you've developed are small and amazing, and the swarm, and Garrick, same to you, the tech of the communications, the mesh in the sky. I think the two of you have some amazing products and technologies that I'm really excited to kind of help bring to life beyond the end of the TRIG program. So for everyone who's with us today, thank you so much. I know we're just kind of slightly running over, but we really appreciate you joining us and listening to both Garrick and his jazz, as well as Rick and his pigeons. So it's been quite an exciting day here with the TRIG drones. Never a dull moment when drones are involved. That's what I like to say. But thank you so much. And as noted by both of them, please reach out and connect, either on LinkedIn, on their profiles here. Rick will be at his booth now if you would like to stop by his booth, and I encourage you to do so. And if you have any questions, please let us know. We're always happy to discuss further. But thank you, Rick and Garrick, for joining us. And thank you, everyone, for watching and tuning in.
And thank you to Emma for managing this session.
Oh, of course. Thank you so much, both. And thank you, everyone.
Thank you.
Thank you.
Bye-bye.
Bye.